Hi, Barry Vesty from Aura-LED Lighting and Aura-LED UK Operations Director. Here once again just to explain a product that is quite passionate to me, LED panels. The reason it's quite passionate is 7 years ago we were one of the first to actually start manufacturing these products in our Shenzhen site. I'm doing a demo from our Ningbo factory where we do some extra testing. I rip some products apart and I want to just give you an idea of the differences in LED panels. Why? Because it's important to what you install on a job. Now, you may have seen the videos I did with Lux Magazine last year about the Quality in Hong Kong show. We've exhibited these products in Hong Kong Lighting Fair for 6 years. We've been manufacturing them for 7. I want to start by explaining our original versions and explaining why we made like we made. So I look at one of our original panels. This is our original panel here. And what you've got is a full-formed aluminium tray that wraps around the PCBs at the edge. The LEDs being on a PCB down the edge means that the heat goes sideways into the frame. By having a full-formed aluminium back, the heat comes out and this becomes a whole heatsink. That lowers the actual junction temperature on the LEDs and makes it better for the LEDs to survive longer. We use that on a demo that we show some customers, which is a cross-section of a small panel, which you can see we've got a full-formed aluminium back there. You can see how we're using a 5630 diode, the original one. We're using 5730 Epistar LM80 approved diodes on our manufacturer at the moment. This panel is actually a 4mm light guide plate that is imported from Taiwan. Very high quality light guide plate, won't discolor. And at the front we use a self-extinguishing PC front cover for diffusion, which splits the diffusion. A lot of the customers like our surface quality as well, the light output from these. Now, what's happened in China is this whole first principle with everything has been made cheaper. And we also have made a cheaper model, but I'd like to explain the cheaper models that are available on the market. What's tended to happen is this type panel has come along, which is what I call a jam sandwich. Now, I'd just like to show you what is in a jam sandwich by coming to this little one that I've ripped apart here. What you've basically got is a sheet steel back that's screwed down to the frame. This one actually uses a very, if you'd like to come in and just show this one uses a 4014 diode, which is a very narrow diode, and they're all spaced very close together. Now what actually happens then is the heat is higher on that point. You're only using the aluminium frame then for the actual heat dissipation, so therefore you can figure that with more heat on the LEDs, you're going to get a quicker deterioration on your L70. L70 is where the lumen depreciation becomes 30% its initial value, just to explain. Now, we've done actual testing on this one, thermal testing, tested it against another competitors, and it runs up to 30% cooler than other people's panels. The market obviously came down and we had a mass deduction in prices being cut all week. There are panels on the market in China for $10, $12. For cheap markets, Russia, India, these are sometimes the worst of the screw down type. What they'll actually use is a non-self-extinguishing front cover. They use a very, very poor light guide plate. This is a poor light guide plate from one of these. This is actually just over 2mm thick. The uniformity, what you've got on a light guide plate is you've got a pattern on the back that the LEDs fire into and then it bounces off the print. If the print is very poor, which it is on this one, you will actually get blotches on the front and it won't be very uniform going forward. We actually test that. It's something that's very, very important to us. Now, with our LED panels, on all series, we have full TUV-GS approval, which means that we've been glow wire tested to 850 degrees on the front. They come with full strain relief, so the cable can't come out. All of our drivers are twist lock-in, non-flicker. All of our panels are non-flicker. So on this one, you'll get no flicker whatsoever. You'll get a very uniform light out of that with the 4mm light guide plate and the 5730 diode. With some new diode formats that came out, one of them was a 2835 platform, which has been heavily produced in China and has LM80 as well. We decided to produce another version where we didn't need to use the full aluminium back, and this is that version. As you can see again, with this, the way we've designed it is you have a runner rail, so all of your fixings can quickly lock into the runner rail. Just there's a nut inside there, locked in the runner rail, you just screw down. No need for silly fixings. Again, full cable grip that we've got here. That stops any cables from coming out, getting torn on your PCB. The frame being wider, we've got a much better heat dissipation on the back there. This one actually uses a 3mm light guide plate, but with the 2M, again imported, high quality, high uniformity. This is actually a test sample that we've got. We don't stock this one. This is a test sample that we've mocked up with the UGR19 micro-prismatic diffuser that we get. We come in. We generally do this with the PC Smooth diffuser, again glow wire tested. Now, there's a reason why I tell you about the cheaper panel formats. If you look at this one, which is a cheap panel format that is screwed down, look how the cable grip has come up here, okay? This has just been pulled, and what you've got this aluminium shear that, now I can cut my finger on that quite easily. The cables could snare on there and quite easily cut. Somebody could cut their fingers on this. It's a cheap construction. It's a cheap construction, and it will cause problems in the future. I always believe if it's cheap at the back, then it's going to be cheap in what is used inside. Either multiple diodes on a thinner format, which creates more heat, therefore quicker L70. The driver is very, very important to panels, as is the EMC testing. So you're looking for harmonics on the PCB, a wider PCB, higher quality PCB. We only use UL approved PCBs. Why? They have a higher copper content. So therefore your resistance down the PCB is much better. We have lower EMC values. The SDCM, macadam ellipsis, is also important. So on this one, we will get under 3 SDCM on all panels. On our Eco panel, without the micro-prismatic diffuser, we're on under 4 SDCM on all panels. So the color tolerance all the way across the board is very uniform. Now, these have been installed in massive projects. We've got a lot ongoing. We've got, for example, Birmingham Women's and Children's Hospital, direct line head offices in London. We've got chains of subways using our panels, post offices using our panels. We've got chains of hospitals, private hospitals, all installed. Long installation, good guarantees, without failures. We have not had big failure rates. We don't get products back. There are some copies of our products on the market. You'll see a copy there. Again, poor strain relief. That's the only thing I'm going to really say. We haven't ripped this one apart, so I can't tell the diode usage. Diodes being important to a panel as well as the quality of material. But it just gives you a brief insight why we have our panels like we have and why sometimes they're more expensive. We have the USA version, we have DLC 4 now, we have full UL and DLC. We have full TUVGS on our Eco panel. We have full TUVGS on our Pro panel, which is our Pro version there. You'll see from our catalogue that we have our Pro LED panel. We also have all the German sizes, 620 by 620, that the Pro sizes, again in the good formats, and we have that in the smaller formats as well. I hope you give us a little bit of time reviewing this, and should you have any inquiries, contact us here in China for other nations apart from the UK, or OraLED UK for these products in the UK. Thank you.